Hi, this is Shivra Chatterjee. Welcome to my Math News channel on YouTube, where I post videos exploring the use of mathematics in art. In this video, I'm going to explore the use of golden ratio in architecture. But before we get into that, let us try to understand what is the golden ratio and why is it called so? The golden ratio is denoted by the Greek letter phi and has a value of 1.618. When this golden ratio is applied in art and architecture, the results are aesthetically pleasing, and hence it is called the golden ratio. If we build a golden rectangle whose sides are in the golden ratio, turns out that the rectangle has some interesting properties. If a square with length equal to the shorter side is removed from the rectangle, it yields another smaller golden rectangle. This process can be repeated any number of times to divide a golden rectangle into smaller and smaller golden rectangles, a property known mathematically as self-similarity. If circular arcs are drawn joining the opposite ends of every square, it yields the golden spiral, one that is widely seen in nature, in seashells, pine cones, and in the arrangement of petals in a daisy. Let us now look at the use of golden ratio in the Taj Mahal, CN Tower, Parthenon, and the Great Pyramid of Giza. Taj Mahal is a mausoleum of white marble built between 1631 and 1648 by order of the Mughal Emperor Shah Jahan in memory of his favorite wife, Mumtaz Mahal. So, is the golden ratio part of the design of the Taj Mahal? Well, it appears so. From the overlays on the picture, we can see that the height of the building to the height of the base of the dome is in the golden ratio. The proportions of the main building are in the golden ratio, as can be seen from the golden rectangle in black. The distance from the left minaret to the end of the central arch and that of the right minaret to the central arch are in the golden ratio. An icon of the Toronto skyline, the CN Tower is a communications and observation tower in Toronto, Canada. It houses several observation decks and a revolving restaurant. The main observation deck of CN Tower is located at a height of 346 meter, while the total height of the tower is 553 meter. The ratio A plus B by A in the picture above comes to 1.62, which is again very close to the golden ratio phi. Built in the 5th century BC, the Parthenon is an ancient temple in Athens, Greece, that was dedicated to the goddess Athena. Several interesting observations can be made by overlaying a golden spiral on the front of the monument and carefully looking at the golden rectangles of different sizes. The width to the original height of the Parthenon is roughly in the golden ratio. Now this assumes that we measure the height from the second step. The height of the monument to the height of the columns is also close to the golden ratio. The height from the bottom of the beam to the top of the monument and that from the top of the beam to the top of the monument is also roughly in the golden ratio. One of the 7 wonders of the ancient world, the Great Pyramid of Giza, is the largest Egyptian pyramid. Built around 2600 BC, it served as the tomb for Pharaoh Khufu. It stands on a square base with sides measuring 230.3 meter. It is 146.6 meter high and has a slant height of 186.4 meter. If we construct a rectangle with the half base as the shortest side and the slant height as the longest side, as shown in the picture, we would get a golden rectangle. The ratio of slant height and half base, which is 186.3 divided by 115.15, yields a value of 1.618, which is the golden ratio up to 3 decimal digits. Extending this golden rectangle, as shown here, we can see that the ratio of the sum of the slant height and half base to the slant height yields 1.619, which is again very close to the golden ratio. It is hard to be certain if the architects of the Great Pyramid indeed used the golden ratio, but it is fair to conjecture that the presence of golden ratio in the design of the pyramid may have added to its timeless appeal. I hope you enjoyed this video on the use of golden ratio in the world's most iconic monuments. In the next video, I will explore the use of mathematics in music and look at the stochastic music of Iannis Xenakis. If you want to learn more about this topic, or in general just explore the use of mathematics in different arts, please read my math art blogs on Medium.